I think what we are doing is really trying to support the teaching of computing in schools, and particularly to support teachers being able to teach the subject confidently. What is Codio? Very quickly, Freddy's really going to give you the glorious sort of inside detail on Codio and show you a lot of the resources and how the platform works and what we provide for you. But Codio is a cloud coding and course content platform for teaching computer science in schools and universities. Codio is lots of parts, including a platform with a powerful IDE and coding platform, really for primary through secondary, into university and beyond. Different from being just a platform, we've also chosen to invest quite significantly in teaching resources, content, and you can publish inside the Codio platform, and a lot of today's presentation is going to share with you those resources that we have created. And support, the third pillar here. A lot of what we do is actually thinking about the experience of teaching computing. How can we unlock it in a way that actually makes the teacher feel more confident about the subject, particularly through things like taking away the burden of setting up schools or classes or environments for teaching computer science, but also in the way in which content is created that supports the teacher with assessing and tracking and monitoring student progress towards learning outcomes. So Codio is a complex proposition that we have tried to simplify as far as we can in terms of supporting the teacher to teach the subject confidently. If we can flip on to the next slide. Lots of pain points that we observed. Firstly, lots of teachers saying, this whole space seems to be flooded with resources. How do I know that I've got a set of resources here that actually helps me deliver a curriculum? We've had a lot of technical problems as well. People saying, we've got this local server, we've got lots of software downloaded, we've got, X or Y running, but it's not very stable, the kids can't use it at home. How do we solve that problem of just making the access to these resources and access to a platform like this really simple? We've got people saying, I don't want another system that is on top of my existing MIS or my VLE or my SIMS or something else. So how do we actually make the information about what students are doing and how much progress they're making, better, but not a burden for the teacher? How can I track and monitor progress? People saying textbooks, great, fantastic, but actually I need some technology for people to engage with now, and also something that keeps student project work, sort of secure and controlled. So if we flip on, I'm going to hand over to Freddy in just 30, 40 seconds, but we have spent considerable time thinking about these problems and the pain points that we observe with teachers teaching the computing subject. We've focused, I guess, number one, on curriculum-matched course content. Not just programming or coding, but things that speak to computational thinking, algorithms, all of the broader non-programming elements of a computing curriculum. We've also spent time on a teacher dashboard, so lots of ways of helping schools get set up, lots of ways of putting interesting challenges and assessments into content that are auto-marked, that really help teachers with the student tracking. We think we've created something that's quite a uniquely engaging experience, and you'll see that from what Freddy's going to demonstrate in terms of the way in which the resources are brought to life in the platform. We think that experience side, the teaching experience, but also the learning experience, is really important. We think actually providing access anywhere is a critical thing. One of the very first schools we engaged with, the students spontaneously said, it's just so easy to engage with this. I can use it in the classroom, I can use it when I go home. They're getting so much more out of it. We actually think we save schools quite a lot of money on the IT cost setup, admin side of things. And we also provide quite an unlimited resource in terms of what students can actually do with the platform. And that's probably the best segue for me just to stop and just tell you about what we've been doing to address pain points and let Freddy show you what we've actually built. I'm going to hand over to our founder, Freddy May.
So the first thing I will show you is, if you like, this is the dashboard that everybody will see. Teachers, students have access to a number of features which are all aimed at the teaching and learning process. So the first thing is you can organize things into classes, and we've got an import capability, so you can export from your MIS system and populate classes, create user accounts. I'm sort of viewing this as a student rather than a teacher, so you have different views. So if I click on this class that I'm in, you can see here that I've been assigned 3 different modules: Introduction to Programming, Fundamentals of a Computer System, which is sort of part of the content from the Cambridge MOOC. And has anybody here used Little Man Computer? Please say yes. Right. Well, we've seen so much serious pain in the teacher community and the student community as well, that we sort of took the decision we were going to rewrite Little Man Computer in a web-based environment, which meant that people just hopefully wouldn't suffer so much. So I'm going to show you a little bit about that as well. A teacher will see a slightly different, they've got obviously a little bit more control. So if I quickly go to classes for a teacher, that is actually the replacement for Little Man Computer. The teacher sees a different view. So there's the same class, 8B Computing, with the same modules, but the teacher also can work with other teachers and can manage whole lists of students, and can also see here, this is coming in about a month's time, has full visibility on the progress of a whole class over the whole course, multiple modules, or right the way down to an individual student. And here's the module Introduction to Programming and the different units in it. And from there even it's possible to drill into the student's code and actually maybe grade a project that the student's been working on. So there's a lot of functionality here aimed at supporting the teacher and the student. So we've organized things into courses, and it's also possible for for the more advanced teachers to create their own courses. And we've got a whole authoring and publishing tool which lets teachers create their own content. I'm going to show you some of that content in a second. In fact, I'm going to show it to you right now. So let me just switch to my student view of things. So if I look inside, for instance, the Introduction to Computing module, you can see that's made up here of a bunch of different units. So this is actually an introduction to programming using JavaScript, which we're strong believers in because it's the most widely, I'm going to probably see some nasty glances here, but it is the most widely used programming language in the world. I think it's one very good approach to get them in the direction where they can actually apply these skills in the real world, building stuff on their phones. However, we're also doing exactly the same stuff in Python. So everything, the bits I'll show you will also be available in Python in the same way. We're also later on in the year going to be doing C++ and Java for those who like that particular flavor. So if we look at this very first one, what is a program? Well, here we are now inside that particular unit. So this is the very first unit of the very first module, designed to introduce people. It's up to, we've seen some people at the primary level using this. We wrote it with sort of Key Stage 3 in mind, and all the way up to vocational learners, people who know nothing about coding. So as Philip was saying, there's all the curriculum mapping capability. Here we're describing some basic concepts of sequences of instructions, and we start to represent those initially in a Scratch-like format. As we move through our content, you can see here, by the way, you've got sort of access to all of the pages in the unit. As we move through it, the pages change, and you get brand new starting points. So, for instance, here we're actually giving them a challenge. So, construct. We've been telling them about how to make a cup of tea. Now we're going to ask them to do it using this is actually Blockly. And we've littered our, wrong word, but we've littered our content with challenges. So when I, for instance, run this here, it's telling us we've got it wrong. If we've got it right, it would say, well done. And whenever a challenge is run, it feeds that information back into the dashboard, so the teacher's able to monitor progress. And the more advanced students can, if they want, can go flying off ahead, and they could probably do the entire module of 10 units in a day or two if they wanted to. So the teacher can use this in the class to pace things and maybe concentrate on the less able students. We've got a lot of extra little things built into Codio, like here we're just introducing the concept of algorithms, for instance. And we all saw Paul Curzon's talk this morning, so this might be the sort of once you've done the unplugged stuff and you've really done all those sort of those initial stages of thinking. There comes a point when you do actually want to turn it into something real. And before you even get to your code, a good way of visualizing what you've been describing as a sort of pre-coding stage is to use flowcharting. So this is actually built into Codio. You can create your own flowcharts independently of these tutorials. This is actually just integrated into it. And so you've got a fully capable flowcharting system with lots of, it's not overly complicated, but it lets you actually do plenty of stuff so that they can achieve what they want without sort of being bogged down by lots of features. You can also, for instance, export this. So if you're doing this as part of a continuous assessment thing, you can export it, copy it into the document that you're going to submit. Here we go on to a slightly more advanced one. And then we go on, I'm not going to bore you with all of this. We introduce, again, we're introducing the concept of text-based languages and how you might describe using a text-based language that tea-making concept. And now we're giving them 3 challenges. Something else that's actually, we hope, very useful for teachers is if the system detects if you're a teacher, and if you are, you get the solution. Now, there are lots of, I suspect that most of the people here are sort of closer to the cutting edge of teaching this subject, but we think that there are probably an awful lot, maybe 90%, who are quite simply terrified and have no resources, and they're forced in a way to sort of say, right, this lesson I'm going to teach Unit 1. So I'm going to go away the day before and I'm going to read up on this stuff. And then in the lesson, they can work through it and they don't have to sort of feel nervous that they're going to be shown up by the kids in the room because they've actually got the solution in front of them, whereas the kids who are doing it haven't. So these challenges are taken by the kids, the solution's not shown. What I will then show you is, let me show you another one of these modules. So for instance, if I look at, I don't know, let's look at loops. So let me just start this up. So here we're talking about loops. I'm going to skip sort of right ahead to something down here. So this is actually a challenge. So now you can see a slightly different view. What we've done as we get past that very initial module is we actually provide sort of engaging, we hope, engaging scenarios such as games. So we've got a game here, a very simple maze game, 2D maze game, that during these 10 units, the students are actually controlling. So they can add things to the maze, they can control all sorts of different things. They've got simple ways of creating a maze with one instruction, and they're invited basically to ultimately create the game and control it, the scoring. The game actually plays, and this probably isn't going to please everybody, but it also makes sounds, all sorts of different sounds depending on what you're colliding with. And here, for instance, we're explaining, we're giving them a challenge to do. So the challenge is modify the loop so it only adds 8 walls, add an instruction to the same loop so it also adds 5 energy stores. Again, here is the solution down here for the teacher. Now, everything in Codio is fully live, so you can change things as you want. So if I change that and reload my game, you can see it's now only got 3 walls put in there. So all the way through this content, obviously I'm skipping over huge amounts, we're encouraging the student to actually learn by doing. So not just the challenges, but at any stage there, say, well, hack the code around. If you want to go and hack it and see what happens, go hack it. And we get asked when we do some presentations, well, can I hack these boxes and get out and try and do some hacking? And we say, sure you can. And that's a big point of relief. If you've got this stuff installed on your school networks, we've seen lots of network managers who are kind of paranoid about that. This all runs in the cloud. Each project is fully isolated from everything else. That they can hack to their heart's content. They're not going to do anybody any damage, except they might get a nasty email from us if they start launching denial of service attacks on people, which has happened. Yeah, so again, here these challenges, they're designed to reinforce and help the student internalize, feed through to the dashboard. So we're building a lot of this content, not just I talked about introduction to programming in different languages. We then have more modules for reinforcing the knowledge. So this is designed to be introductory, but then there comes a point when you actually want to sort of have them really internalize it with little challenges. Again, we've got lots of challenges just about to come, which let them get deeper and deeper, get comfortable with the programming language, and then you can move on to more advanced things. So we've got courses coming which use APIs, Google Maps or the Guardian news feeds and different things like that, where they're actually doing project-based stuff. And then we've got more advanced stuff. In fact, we're doing things, I was just telling Simon we're doing one on Haskell for sort of probably university level stuff. So also web development. So we're seeing a lot of schools where the teachers are actually teaching HTML, CSS. So we've got a really nicely paced course which will be available by September, which teaches them just that introduction to HTML, CSS, gets them to the stage where they can build web pages, really quite nice ones if they're talented, otherwise probably boring ones. Then they can start adding in some of this programming knowledge that they've learned, and they can start making interactive sites. And again, the more advanced kids can go off at speed, otherwise the less able ones are supported by the content. When it comes to project work, so let me now go out and actually, I'm going to switch back to my other browser. You can also say, right, I want to go and do a particular type of a particular project. And for that, I want to have a sort of a complete control over everything. Now, one of the things that sooner or later they have to get to grips with, probably more late key stage 3 or 4, maybe earlier sometimes, is using the right tools. And one of the reasons we decided to focus so heavily on education is a lot of the sort of Codecademy type things, really they give you a very sandboxed environment and you're hitting your head on a ceiling, sometimes without realizing it. You're led along all the way, and actually it's perfectly possible to have learned nothing. What Codio does is it can lead you by the nose if that's what the content is designed to do, but it also can take you right the way up into as far as the professional world. So if I want to actually just say, right, I want to write a coding project, for schools, we've given the common stacks that people have asked for, but actually you can choose anything you want. So if you were teaching something more advanced, you could come in here and we could say, well, maybe you want to teach okay, for your benefit, Simon, Haskell. Or maybe you want to teach, if I look for Python. So, and what these also give is, we actually see quite a lot of people doing LAMP stacks and PHP work. So we kind of support everything. So if I did want to have set up WordPress on here, I can come and sort of create myself a new project. And now I'm getting a brand new server. So every single project that a student has, although they don't need to know this, has a full server at its disposal, spun up immediately. I can now, like with any IDE, I can start creating my Python file, for instance, and start editing it. Again, for the sort of more advanced students, if I want to, I can access a terminal on there. And if I want to install software, again, we've looked at every level to really simplify. So I can remove the complexities of installing stuff. In fact, this box has already got Linux, obviously, Apache, MySQL, PHP installed, because that's what we did from the stack. But if I wanted to, on here, parts install the Scala programming language, for instance, not that anybody in schools is going to want to do that. I just type parts install Scala, and that's already installed. Because it runs in the cloud, the product itself, everything that happens is unbelievably fast because it's going from the cloud to the cloud. You're not coming into your school networks. Similarly, same way I would install PHP, lots of other different programming languages. So you've actually, if you want to really go down to these advanced levels, you can go a long way. Now, even better is if you've got teachers who say, right, I want to teach a Python project and I have a starting point and I'd like to get instantly to that starting point. If I go to starter packs here, and let's say I wanted to do, for instance, we see a lot of people using Python and Tkinter. So if I set up, we've just added this feature in very recently. So if I say, right, we've got a Tkinter widgets starter pack, this gives me Python, all ready for Tkinter, all the modules installed, plus some code. So if I now go create on that, again, it's creating my new box with all that stack on there, and additionally, I've got all of the projects that I want to work on. We can also, with those starter packs, create nice little helper menus. So if a teacher wants to start with as much friendliness as possible, you can configure these menus. Every student that starts it gets this. So if I, for instance, wanted to look at, I don't know, Canvas plot, I can come in here. Here's the Python file. And I can now say, OK, let's run that. So in fact, for this one, I just say start current. And that spins it up. Now, this is a real sort of thing that we put a lot of recent effort into. Normally, Tkinter requires that you're running it on a desktop and you've got your own graphics card and stuff. All of our stuff is running in the cloud. So we put in a system which actually sort of gets around it. So now when I press that button, I'm actually able, even though this is all running in the cloud, to run to Kinter. In fact, it will not run, it won't just run to Kinter, it'll run anything that writes to the screen. So this is something that, again, when you think about the complexities of setting up to Kinter, and it is pretty complex if you're doing it, that means that you're probably going to spend time with your systems administrator trying to get it set up. Great, it does. The kids come in for their lesson, and then they say, I've got to do some homework. They can't, because there's no way you're going to set up something like Kinter on 30 kids' machines at home. Like this, they can go home, they can log into their account, and they can carry on exactly where they were. I mentioned a little bit earlier on the Little Man computer. So this is another example. Well, actually, before I leave this, what I will do is just show you, if I wanted to add into this, for instance, if I wanted to do a flowchart, to create a flowchart, if you're doing that as part of a project, I just say new file, test.flow. And now here we've got a flowchart tool. So we can now start, my mouse zooms in very rapidly. Well, this is a nice thing about this is you see you've got this little mini-map. So I can zoom in and go and find stuff. More importantly, if I've got a huge flowchart, which some people may well get to, and you can't see everything on your screen, it's also not, you don't want to zoom in all the time, so I can just go and pan around my flowchart. So you can build these things, as you saw them, we can have them integrated into those guides, or you can just say, right, we're doing a project, here's an algorithm, document it using the flowchart, then go and code it up in Python, for instance. So you can do all of that very easily without having to use external tools. Same thing is Little Man Computer. If I want to create a Little Man Computer project, and I think Little Man Computer, by the way, did a great job. It's just, it's old now. But I decided to do this because my son is doing GCSE computing at my behest. Well, not behest, but he thought my dad's some sort of geek. I'm going to go and do it. 6 months later, he's bitterly regretting it. And Little Man Computer was one of the reasons that, he just thought, what is this? More to the point, the teacher in his class thought, what is this? He then said, he just told me the next day he was going to be doing, his continuous assessment was due. I just had a bottle of wine or something with my parents, and he said, would you help me? And I thought, it's 10 o'clock. So I thought, all right, this can't be too hard. I didn't get to bed till 2. It took me 2 hours to install the thing. Then I found, without knowing, that there were 2 instruction sets for Little Man Computer. Then I had to deal with a slightly fuzzy head. I had to deal with the algorithm, which was the Fibonacci sequence. My son hadn't even really mastered the concept of a loop with a counter. So anyway, having gone through this and then heard out with teachers that they're suffering similar problems, I thought, right, we're going to deal with this and we're going to rewrite Little Man Computer. So we did that last month. And let me show you what we've done. So I hope this is kind of proper pain relief for people. I'm just going to go and find where let me go and get it from here. Let's use this one here. This is just, I'll take it from the project. Right, so this is what we've done is we've wrapped this up inside a guide. And the reason we've done this is one of the big problems I found when using Little Man Computer is the documentation is everywhere and nowhere. It doesn't really exist, so we're going to document it properly. So we've done a video for it. And there's a help page you can link to which describes it. But what we also did was to try and make it as easy as possible to use. At the end of the day, it's kind of odd that you're teaching assembly language to 14-year-olds or 15-year-olds. So we thought, well, if you're going to do that, let's make it really as usable as possible. So here, for instance, things like when I actually want to run this bit of crunch, you've got a very simple debugger, so you can actually step through your code. And you can see what's going on. That in itself is kind of very, very easy for people to work with once they've mastered the concepts of accumulators and registers and things like that. That's one thing. You've got a very friendly debugger. Other than that, it does all the things that Little Man Computer would do. We've also added some stuff to the instruction set, because when looking at that, I was thinking, well, how are you going to teach how to multiplication things if you haven't got or if you're teaching a general algorithm, and one of the steps within the algorithm requires multiplication, but there's no mul instruction in a man computer. So you're asking them to sort of deal with two levels of abstraction, which is not the intention. So we thought, okay, we're going to sort the instruction set out. So we've added a few things that we think are just essential if you're going to not have to deal with that level of abstraction. So this might be looking a little bit small on your screen, but as you can see here, we've got all the instructions are available through a drop-down, and they're explained in place. And then when I select one, you know, it just comes in, or I can type. So if I wanted to store something, you can type it too. Also then, well, if I'm going to store it somewhere, let's provide the dat variables here in the list. So it's sort of, the idea is it's just trying to make it as easy as possible so that the kids can focus on the computational thinking, which is really what you should be trying to teach them, rather than the assembly language syntax. So that's Crunch. But that also comes with a bunch of challenges. So for instance here, this is the, and we've written these challenges. There are about, how many of them are there? About 15, 16. We've written those as carefully as we can in gradually increasing order of complexity. So you're not given the Fibonacci sequence as the first thing to do. Here we're given, you know, input a value, output the result. Well, that's a pretty easy thing to start with. So you come in here and you add an instruction, INP, and you add another instruction, OUT, and we can step through, we can run it or step through it, or we can just test it, and it says, well done. Again, feeds through to the teacher dashboard so they can monitor how far through they're getting. We also monitor the amount of time, by the way, that every student is spending in these modules. If I were to get it wrong, so if I were to sort of increment the accumulator here at this point and we check it, you can see it's got it wrong. Something else, just sort of, again, to show how we saw that this was being used in one little language. I can't remember what language it was, but it was a very obsolete one and one that probably shouldn't be taught. But one feature we picked up from there, which was, I thought, incredibly useful, was, and when I sort of think about new languages that I learn, I don't spend that much time learning new languages, but when I do, the one thing I want is really good supporting material. Yes, the internet is flooded with it, but it's an algorithm itself to kind of figure out what's good information and what's bad information. So we thought we would at least try and find the best sources or write stuff ourselves to make this information available in here. So if I was doing, for instance, writing some JavaScript, and I'm sort of, okay, that's not the sort of nicest starting point, but let's just say I was stuck, and I said there's this thing called if, or a for loop, and I just can't remember how on earth it works. We have just started doing this. We've done it for JavaScript. We're going to be doing it for Python and a few other languages. You can just bring up your lexicon, and the lexicon is, so if we can get through to it. Don't let me down, lexicon. Here it is. So what the lexicon, it lets you select your topic, and we're going to be populating lots of different topics. So JavaScript and Python initially. And now I can just say, well, yeah, it was for. And you can then see, oh, there's for. And now I can sort of read up and see, oh, there's an example. Okay, now I remember. I'm doing some function, I've just been exposed to string, playing around with strings. And I know there's that there's that something like slice or whatever it is. So there it is, and same thing. They go and find. Oh, now I remember. So that means that they don't have to go and trawl for information. Everything's at their fingertips.
Describe how you access databases.
How you access databases? Well, if I'm in this project here, for instance, I mean, you can choose your database. Because the box can do anything you like, the first thing is you can put anything on there that you want, MySQL or MongoDB. You can install them really, really easily. So it's as easy as this. And this is now going to install MySQL.
And does it do all the way, do you have to register yourself as users, or are you automatically connected?
You're automatic. In fact, it even you can see it's activated, it's installed it, and it even tells you how to start it and stop it, or you can auto start it. Then how you access that is what you would do in practice is because what you don't want to be doing is in the class is what I just showed you. So what you would do, and I can show you this actually very, very effectively because this uses MySQL. So let's just say, for instance, we were teaching WordPress. You come in here, I create my project. This spins up now something with WordPress installed, with MySQL, PHP, Apache, all installed, and it's ready to run. In fact, if I press WordPress, might have to...
That student is registered
Whoops.
as a user of MySQL as that individual. They don't need to put usernames and passwords in to be able to access the database.
It depends. I mean, if they're doing it from basics, then you have to configure it fully from details. But this way, for instance, you know, this here you're using WordPress. This is part of the installation.
I don't know about WordPress. If you're using PHP, for example, would you have to set up as an individual user, or when it's installed, does it install for them as an individual?
You can do it. You can do it both ways. So with the starter pack, which is the thing I just showed you, you can pre-configure it. So it's like here, you've got these configuration files in here. You can have before they create this, you can just make the modifications in here for the class, create your starter pack out of that, and then because every individual is getting their own discrete box, we call it. It doesn't matter that you're using exactly the same username and password, which are just generic username and passwords 30 times, because they're fully isolated from one another. And even better, they all have got exactly the same username and password, so you don't have to deal with the fact that you've got 30 different ones in your class. They've got their own totally independent database. So if one of them goes and hacks it to death, that's the only kid who's going to be affected by it. Yeah. So really, the bottom line is you can do, apart from Microsofty stuff, sorry, Simon, apart from Microsofty stuff, you can do absolutely anything else, and you can make it as complex as you want for them, because sometimes you want them to deal with complexity, or you can make it as simple for them as you want.
If you would like to engage with Freddy or I, you can contact us directly. These are our email addresses. We have started doing something that we found really useful with teachers, which is a series of webinars. We're doing them, we've got one on Monday, one on Tuesday, one the following Monday, and then we're going to try and get some sort of pattern emerging here. They've all got a short code, Codio webinar, day, month, apart from the next couple, Codio webinar 2, webinar 3. Those are the dates. They're all going to be posted on the CAS events forum, and they're free. It's a 45-minute thing, no heavy sell at all. It's just let's have another look at some of these resources, come with questions, things you'd like to find out about. We'll show you, like Freddy has demonstrated this morning in the platform, and then there's ample time to have some live Q&A as part of that webinar. We've produced an Ask the Experts series. We're filming again today with some people. Follow us on Codio. Lots of video stuff we've shot with how to teach computing in schools, top tips from some of the CAS leadership and so forth. But feel free through any of these contact means to talk to Freddy or I, join our webinars, or follow us for updates on any of these channels.